Welcome to this podcast on architectural acoustics. In this podcast, we are focusing on sound and acoustic history, but I like to just make it clear that we are speaking about a very, very brief outline of the history in the nature of a podcast format. As early as 500 BC, Pythagoras discovers the relationship between frequencies and vibration. Pythagoras, of course, is very known for his works with mathematics, but his works in acoustics may be even more fundamental to the development of this field. The Greeks also created the small intimate theatres called odia. These were made specifically for acoustic experiences, and they were roofed constructions, not open as the amphitheatre we see here, which is perhaps much more famous than the odias that were used in the Greek society as well. This particular case is from the Epidaurus, one of the most famous amphitheatres, and it could house about 17,000 spectators. In these amphitheatres, it is clear that the Greeks had a very strong understanding, at least on an empirical level, of the propagation of sound and acoustics in general. So here we see a spreading and the possibility of an omnidirectional spreading, and that the amphitheatre is organized in a way that it covers a bit more than 180 degrees. Furthermore, the amphitheatre is sloped in a way that makes the distance from source to receiver at different locations minimum. Also, the amphitheatres are placed in conditions or locations which has minimum background noise, which improves the signal to noise ratio, which in turn improves the intelligibility of this space. And in about 300 before BC, Aristotle understands and describes the propagation of sound through material and publishes the seminal work on acoustics. It is suggested in the literature, however, that Aristotle did not himself write it, but had a group of people writing the publications for him. Much later, Leonardo da Vinci studied what now is known as the equation of continuity, which led to the derivation of the wave equation that we use today. Later again, Galileo Galilei understood the relationship between the frequency of a stretched string and its length, tension, and density. And Isaac Newton describes in his Philosophia Naturalis Principia Mathematica that the velocity of a sound is proportional to the square root of the isothermal velocity of sound in air. So here there start to be more detailed descriptions between the propagation of sound and the medium that it travels in. Later, 1700, Leonhard Euler publishes a partial differential equation for the modes of vibration in a stretched string, and Marie-Sophie Chalmin describes the fourth-order differential equation that describes vibrations in plates. These discoveries are not necessarily to do with architectural acoustics, but acoustics in general. In 1877, John Strutt and Brian Rayleigh publishes the theory of sound, which collects a series of the findings and produces a volume which shows the extent of the acoustic theory and ideas and principles. Almost at the same time, the sensations of tone are published by Hermann von Helmholtz, which describes the frequency or the relations between frequency, wavelength, and sound, and includes mathematical descriptions of these phenomena, which includes equations of the frequencies, wavelength, propagation, which many of our descriptions today are based on. In 1922, Wallis Zabin conducts studies in the Folk Art Museum from the request of President Eliot. Here, he describes the relationship between absorption of materials and sound decay, which leads to the very, very central description of vibration time, which we use in almost all measures of acoustics today. It is said in the literature that Sabine took blankets and pillows from neighboring buildings and positioned them around in the auditorium to understand how these materials influenced the reverberation time and the decay of sound in the space. He conducted his studies during night in order to have as quiet an environment as possible to work and understand the sound decay of the space. It was shown later that the Sabine equation was most suitable for live spaces, that is, spaces with a longer reverberation time. So in 1930, Ehring publishes an extension to the Sabine equation based on Norris's work, which is more correct and more usable for dead rooms with shorter reverberation time. This was further extended in 1933 by Middleton and Sette, who separated the material coefficients in the equations and thereby allowed a higher specificity and description of the space in relation to the sound decay. Another pivotal moment in the history of sound and acoustics was through the two publications by Schröder in 65 and 70. Here, he found that he could, based on the energy time curve, make a plot through a backward integration, starting from a given time point and tracing backward. This gives a slope that from which you can compute, or which one can compute, the reverberation time at different intervals of the decay. It actually provides us with several slopes depending on where we look at this plot, which led also to the definition of the early decay time, T30, T15 and so forth, just as the backward integration and the Schröder plot today is used for many measurements or calculations of different acoustic phenomena and descriptions. So, in summary, studies in sound and acoustics has been conducted since before 500 BC. The development and knowledge of sound is closely related to acoustics, and acoustics can as such be understood as a science of sound. The Greek and Roman cultures had deep understanding of sound phenomena, if not only on a theoretical, then also on an empirical level. And reverberation time became a central acoustic aspect through Sabine's work, which we still use and build upon. Today, acoustics, however, are often described through the phenomena studied through a range of methods related to impulse response. And acoustics today is a complex field of study ranging from mathematics and wave physics to the physiology and psychology of humans. So this again was a very, very brief outline of some of the historical markers in terms of the development of acoustics. Thank you for watching.